Okay, this lesson is beginning to show us how we can solve using logs. Now, yes, some of it is definitely calculator driven, but there's some things that we can do without a calculator. So I want to focus on the no calculator part first. When you take your quiz right before Easter break, and then also when you take your test after Easter break, there's going to be a no calculator and a calculator section. So from going forward, I'm going to try and label everything calculator and no calculator so you understand what types of problems will be on both sections. All right, well, the directions say write as an exponential function and evaluate. So we want to rewrite this so we can evaluate it because as it's written, we don't know what to do. So it's in logarithmic form now, so we're going to change it to exponential. So if you remember, 7 is your base, and the x and the 2 switch, so that 7 squared equals x. 7 squared is 49, so x is 49. See, don't need a calculator. Okay, on the next one, 5 is your base. So we have 5 to the third equals x. 5 to the third is 125. If you're not sure, we've got that chart. Okay, that'll help you get started for right now. Excuse me. All right, next one. This is going to be 25 to the 1/2 power equals x. Well, if you remember from class last time, we talked about anything to the 1/2 power is the square root of a number, and the square root of 25 is 5. So there's our answer. Number 4. This would be 8 to the 1/3 power equals x. Well, if the square root, or excuse me, if something to the 1/2 power is the square root, then something to the third power is going to be the third root. Well, what's the third root of 8? So you're asking what number times itself 3 times will give you 8. Well, we should know 2 to the third is 8. So you should know your answer is 2. If you don't have a calculator and you can't remember, you can always do a factor tree. Okay, number 5. We're going to have 6 to the -2nd power equals x. You cannot evaluate anything if it has a negative exponent. You have to make it positive. So to make it positive, if it's negative in the numerator, then you got to move it to the denominator. So this is going to be 1 over 6 squared equals x. Well, now we know what 6 squared is, so this is going to be 1 over 36, and that is our answer. All right, let's try one more of these. This is going to be 3 to the -3rd equals x. Okay, and that would be 1 over 3 to the 3rd, because to make the exponent positive, you've got to move it. Now we can evaluate, and it's not 9, because it's not 3 times 3, it's 3 cubed, which is 27. So it's 1/27th is our answer. All right, now this next section gives the same thing, but it's not quite written the same way, and it's still no calculator. So this one is kind of asking you to use your facts about squares and cubes and 4th roots and maybe even 5th roots to see if you can come up with the correct answer. So if you're stuck without a calculator and you've got this log that you have to evaluate, how could you do that? Okay, well, the first thing is we need to kind of figure out what we're solving for. So what we're solving for is x, right? So now that it's written like this, now I can rewrite it. So now this is really 3 to the x equals 81. Well, I've told you we can't solve for an exponent, but we can think about the facts that we know and figure out 3 to what power equals 81. Well, if you're not sure, let's take a look at our chart, which is right here, okay? So we're looking... Oops, clicked on one too many things. Here we go. So we're looking 3 to what power is 81? Well, if I come back over here, now I'm on the right thing. 3 squared is 9, 3 cubed is 27, but 3 to the 4th, it's 81. So this is going to be x equals 4, because 3 to the 4th power equals 81. Okay, let's try this one again. If there's no x, we're going to add an x, so now we can rewrite it as an exponent so we can think about what the question is asking. So this is 4 to the x equals 64. Not sure? Look at the chart. Okay, well, 4 to the 2nd is 16, 4/3 is 64, so it's got to be, oh geez, It's going to make you dizzy. It's got to be x is equals 3. All right, let's try this one. We're going to set this equal to x. So we have 7 to the x power equals 49. You don't need your term for this. X equals 2. All right, one more. This equals x, so I'm going to have 2 to the x power equals 32. Well, this might be a tricky one. Well, let's look at our list. Okay, 2 squared is 4, 2 cubed is 8, 2 4 to the 4th is 16. That's not an option. But if we multiplied 16 one more time by 2, we would get 32, which is the answer we want. So we get x equals 5. All right, now we've talked about logs a little bit, but we have to talk about one other thing that goes along with along with logs. First of all, remember e we talked about as a decimal. It's 2.71 something, something, something. Just like pi is a number, e is a number. Okay, so if I have this exponential equation, e to the x equals 70, I could rewrite that in logarithmic form by saying the log of base e of 70 equals x. Okay, well, anytime I have the log to the e, instead of writing log base e, I write ln of 70 equals x. And this right here stands for the natural log. Okay, and anytime, so the log base e is the natural log. That's the same thing. So if our base is e of a log, we use the natural log instead. And so we're going to use those when we're solving here in a little bit. But before we can get more in depth with solving, we have to be comfortable about putting these into our calculator. So the first one is log 78.5 and log 0.24. When you're doing this, well, first of all, nearest 10 thousandths is going to be 4 decimal places. So that's 4 numbers to the right of the decimal. Okay. Also notice on these 1 and 2 it doesn't have a base. If it doesn't have a base, the base is an invisible 10. Okay. Log base 10, when the base is 10, you don't actually write it. You just write the log. When we're putting it to our calculator though, if it doesn't have a base, you don't need to include it. It's okay. You can get away without it. So let's go to our calculator and try and find log of 78.5. So to do that in your calculator, on the left-hand side, over here, you're going to, next to the 7, you're going to find the log button. So you're going to hit log of 78.5. You can close the parentheses, but you don't have to. So to 4 decimal places, I'm going to get 1.894, well, 86 is going to round up, so 8949. Okay, I'm just going to do one of each type since we're not in class, and then you can see it. All right, so now, what if it's not this invisible base 10, but a base 4? Now this we definitely need to tell the calculator what this is. So if you go to your calculator, and you go to the math menu, and we want things that are included. So you can go scroll down, but that's going to take you a little longer. If you scroll up, option A is log base parentheses. So if you hit that option, we want log base 4, and you scroll over and you want the 80 in parentheses, and then hit enter. Okay, and so now we've got our decimal. So the 4th decimal place is the 9, but the 6 rounds it up, so it's going to be 1610. And that's the answer to 4 decimal places. All right, well, what if we had to put a natural log in the calculator? How would we do that? So go back to your calculator, and over on the left-hand side, you'll see a button that says ln. So we'll do the natural log, and I forgot the number, of 50. Hit enter. So we get 9120. And there are answers. And you would do the same thing with these other numbers, just obviously punching them in differently.